Welcome back, 8th graders. This is going to be our last video, my friends. Now, the reason I chose to do this as the last video is because the other work that I was looking at is two-step, possibly multi-step equation. I'm just going to show you the notes in our notes section. I'm just going to add it to a Google Classroom because that is something we have done. Like I said, if you had me last year, we did that. And if because you had me this year, we did a lot of that as well. So those problems we have done so many times. I want you to experience and attempt a more rigorous type of problem. This is the kind of problem you're going to see in high school. It is also a problem you're going to see on various standardized tests. So it's not something that we can skip over. And that's why I want to do this one. We have to get this one done so that you have the experience and the knowledge to do the same type of problem in high school. So let's go ahead and get this thing started. So we're going to write and solve an equation for the following situation. So what the goal of this is, so when we're finished with this problem, the goal is to say, I can write and solve an equation from a verbal description. Okay, I know that might sound kind of confusing for some of you, and that's okay. If I reword it, it's saying I can write and solve an equation by looking at a word problem. Okay, and this is when we talk about those real world situations. So first I'm going to circle all of my numbers. Y'all know me, I do cubes. That is important because it isolates the information that you need. So we have all of our numbers circled. Then we look at our question. What is our question? The question is asking us, how many years will it take before this person and this person earn the same salary? So let's go back and read the question so we can actually find our operation words. Marshall earns a salary of $36,000 and each year he receives a $4,000 raise. Jim earns a salary of $51,000 and each year he receives a $1,500 raise. How many years will it take before Marshall and Jim each earn the same salary? So go back to the beginning. Marshall earns a salary of $36,000 and each year he receives a $4,000 increase, raise. Now this right here, this $4,000, the raise word, the reason why I'm putting a box around that is because it's not telling me operation, it's telling me direction. So when we look at the number line, we talk about the number line being our distance and our direction. I need to know, is he increasing $4,000? Or are they taking $4,000 from him every year? That's important to know when you sign on to a job. If they say you're going to decrease a certain amount of money every year, walk away. Walk away. You want to increase. You want to earn money every single year. Okay? So that's why I put a box around raise, because I wanted you to know that actually is going to mean that the number before it is a positive number. So let's go back. Jim earns a salary of $51,000, and each year he receives a $1,500 raise. So now we know Jim and Marshall. We have their information. We know who earns what and how often they earn it. I'm gonna put a squiggly line under year just so that, because we don't really have to put a box around each, because technically a box around year, because technically we're talking about each year. Each is the word I want you to hone in on. That's the word I want you to pay attention to, because that goes with your slope. Every year there is a constant rate of change. So for Marshall, what is Marshall's constant rate of change? So I'm going to move this and we're going to look at this. So every year, Marshall's constant rate of change is 4,000. This is his constant rate of change. So Marshall has a constant rate of change, or yeah, a rate of change every year of 4,000. And Jim has a rate of 1,500. Now, how do I take the information from the sheet and the information from this board and create an equation? I'm going to show you. So back to my equation. When I have it off camera so you can't see it, but I can. I'm going to still use blue because I'm going to make sure I take pictures of this and upload it. So Marshall starts with $36,000 every year. And so that word "and" means I need to add a plus sign. What is his raise? 4,000 every year is his constant rate of change. Now, Ms. Tyndale, why did you put an equal sign right there? Because the question, if I went back to the original question, the question is saying, how many years will it take before Marshall and Jim earn the same salary? So I put an equal sign because I need to know Marshall. When does Marshall equal Jim? When will Marshall equal Jim? So Jim starts at 51,000. But Jim does not earn the same amount that Marshall earns every year. They earn at a different rate. So because they earn at a different rate, at some point they are going to match up. So the question wants us to find out, when are they going to match up? So when you see a real world problem like this, I need you to think, this is an equation with a variable on both sides. We are talking about a variable on both sides. This is that equation. Now we have the equation, we do like we normally do when we solve it. Get all of your variables on one side and get all of your constants on one side. So let's start with moving our constants. I'm going to take my 36,000 and I'm going to bring it right over here. So subtract 36,000 from both sides. Those zero out, minus 36,000. I bring down what I did not use. So if I do 51,000 minus 36,000, I'm going to get 15,000. Okay? Then I bring down this because I did not use that either. I need to get my x variables on the same side. So I'm going to subtract this from this side. And what I do to this side, I have to do to the other. So if I do 4,000 and I take off, or I subtract 1,500, I'm going to end up with 2,500. X equals 15,000. So I've made my way from a word problem to finding out, to pulling, or we call it extracting, to take out, to look for the information, only the information that I need to use. And I wrote that out. I said, okay, Marshall is 36 a year and he gets 4,000 every year added to his salary. Jim starts at 51,000 and every year he gets $1,500 added to his salary. So that's what we have here. We have Jim and we have Marshall. So actually, I'll go ahead and label them so you can remember which color. This was our Jim. This was Marshall, I'm sorry. This was Marshall. And Jim was red. And Jim. Okay. There we go. So I have Marshall's equation I'm sorry, I have Marshall's expression and I have Jim's expression, and you have to make them equal to each other because the question says, when are they going to be earning the same amount? Am I still in the frame? Yes. I think I moved it. We are going, that's what that equal sign is. At some point, they're going to be earning the same, okay? So now that I've done all of this and I've done my, that's our equation with two variables, so a variable on both sides, then I brought it down and I did my two-step equation. So this is the first step. Now I'm down at the last step. This is our multiplication. So to undo or do the inverse of multiplication is to divide. Bring down the x. Now I've isolated my variable. Then I'm going to do 15,000 divided by 2,500. And my answer is going to be 6. So it is only going to, was that a word? I'm not sure those were even words. Oh my word. Let me start over. It is going to take Jim and Marshall 6 years to be earning the same amount. So in 6 years, Marshall and Jim are going to earn the same amount. So let me see if I have another color. Brown is ugly, but it is what it is. In 6 years, let's see if I can write it small enough. In 6 years, Marshall and Jim will earn the same amount of money. So actually I would say at 6 years. So not really in, it's more like at. Because what's gonna happen is, once you get to 7 years, Marshall, who started off making less money, is going to earn more money than Jim. Because this is where they are going to be the same. But because Marshall earns more money every year than Jim, Marshall is always going to earn more money than Jim. Always. At that point, Jim is never going to make more money than Marshall, even though he started higher. So at 6 years, they're going to earn the same amount of money. Once you get above 6 years, it's no longer Jim making more money. Now Marshall is going to be making more money. So I hope that explains this for you. If you have any questions about this, please make sure you reach out to me before you get to 9th grade, preferably before the end of the school year, because just like you in the summer, my computer goes in the closet and I do not even want to look at it. I need a break. And I'm sure you need a break as well. I know this time has been really rough for you guys, and I know this is not how you planned on spending your 8th grade year, and I'm sorry for that. I truly, truly am. But I do want you guys to know that your teachers, all the staff at Kenmore Middle School, they are here for you. And at any point in time, if you need us, we will do our very best to to provide you with the things that you need. And you guys are in 8th grade, so I won't see you again. My hope is that you take what you have learned in 8th grade and that you apply it in 9th grade. I want to see each and every one of you be successful. I want to see each and every one of you walk across that stage in 4 years to get your high school diploma. So with that being said, you guys have a great, safe summer and best of luck in high school.